Have you ever looked up at the night sky and seen the moon? It's our planet's only natural satellite. But what if it wasn't alone? What if our moon had its own moon? We could call it a moon or maybe a submoon. To understand how this could happen, we first need to talk about how our moon got there in the first place. The leading idea is called the giant impact hypothesis. It's a really cool story. Billions of years ago, when our solar system was young and chaotic, a planet about the size of Mars, which scientists call Theia, smashed right into a young Earth. Wow, that collision was massive. It sent a huge cloud of molten rock and debris flying out into space, which then started orbiting our planet. This cloud of super hot rock didn't just float there forever. Over a very long time, gravity, that amazing force that holds everything together, started pulling all those bits and pieces together. Think of it like making a giant snowball, but with hot rock instead of snow. The bits clumped and clumped, getting bigger and bigger until they formed the big, beautiful sphere we see in our sky today. That's our moon. It's an incredible origin story showing just how dynamic and wild the early solar system was. It's not just a rock, it's a piece of ancient Earth's history, forever circling us in the darkness of space. Now there are other ideas, though the giant impact is the one most scientists favor. One older idea is the capture theory, which suggests the moon was a wandering body, like a giant asteroid, that just flew too close to Earth and got caught in our planet's gravity. Another is the fission theory, where a rapidly spinning young Earth flung a blob of its own material out into space, which then became the moon. And there's the co-formation theory, suggesting Earth and the moon formed together from the same cloud of gas and dust. All these ideas help us think about how planetary systems form, but the evidence from moon rocks brought back by the Apollo astronauts strongly supports the big smash-up. So how could our moon get its very own moon? It would be tricky. The moon's gravity is much weaker than Earth's, only about 1/6 as strong. This means its gravitational pull isn't as good at grabbing onto things. But it's not impossible. A small asteroid, perhaps just a few kilometers across, could wander into the Earth-Moon system. If it passed the moon at just the right speed and angle, our moon's gravity could snag it. This little asteroid would then start orbiting the moon, becoming a true moon. It would have to be in a very specific, stable orbit to avoid being pulled away by Earth's much stronger gravity or crashing into the moon itself. Consider it. Imagine we woke up one morning and astronomers announced the news. The moon has a moon! How amazing would that be? For scientists, it would be a phenomenal discovery. We would send probes and telescopes to study it immediately. We'd want to know what it's made of, where it came from, and how it got captured. It would be a natural laboratory for understanding how gravity works in complex systems with 3 bodies: Earth, the moon, and the new moon. It would challenge our models and give us so much new data to explore. The race to learn its secrets would be on, sparking a new era of space exploration and discovery for everyone. For the rest of us here on Earth, it would be a cultural spectacle. People would write songs and stories about it. It would become part of our mythology and art. Stargazers and amateur astronomers would rush to get a glimpse of this tiny new dot circling our familiar moon. You'd need a pretty good telescope to see it, but just knowing it was there would change how we see the night sky forever. It would be a constant, beautiful reminder of how dynamic and surprising our universe can be. It would inspire a whole new generation to look up and wonder, to ask questions, and to think about our place in the cosmos. Science is all about that sense of wonder. But the life of a moon would likely be a short and chaotic one. The gravitational environment around the moon is very unstable because of Earth's powerful pull. Our planet's gravity would constantly tug on the little moon, disturbing its orbit. Over time, this gravitational interference would make its path wobbly and unpredictable. This is a classic physics problem called the 3-body problem, and it's notoriously difficult to solve because the interactions are so complex. The moon would be in a delicate dance between the Earth and the moon, a dance that couldn't last forever. Its fate would be hanging in the balance. So, what could happen to our little moon? There are a few possibilities. The constant tugging from Earth could eventually pull it out of its orbit around the moon and send it hurtling into space, lost to the solar system forever. Alternatively, its orbit could decay, causing it to spiral inwards and crash into the moon's surface, creating a brand new crater. A more dramatic, though less likely scenario is that Earth's gravity could fling it directly towards us, where it would burn up in our atmosphere as a spectacular meteor. Its existence would be fleeting, a temporary jewel in our sky before gravity ultimately sealed its fate. Now let's try a really wild thought experiment. What if somehow the Earth became much smaller, say the size of our current moon, and the moon grew to the size of our current Earth? Let's call them Little Earth and Big Moon. Everything we know about our world would change, starting with gravity. On Little Earth, the force of gravity would be much weaker, just like it is on the moon today. About 1/6 of what we're used to. Getting around would be easy. You could jump 6 times higher and feel incredibly light. It would be fun at first, like being a superhero, bounding across landscapes with very little effort. But living in low gravity would have serious effects on our bodies. Our muscles and bones are used to working against Earth's strong gravity. Without that constant resistance, they would start to weaken and waste away. Astronauts on the International Space Station have to exercise for hours every day just to combat this effect. On Little Earth, we would all face the same problem. Our hearts, which are also muscles, wouldn't have to pump as hard, and they could shrink. Over time, our entire physiology would change, and we'd become much more fragile beings, adapted to a world where everything is lighter. It would be a huge challenge for human health. Now, what about the Big Moon? If it had the mass of our current Earth, its gravity would be incredibly strong. If you tried to visit, you would feel crushed by your own weight. Every step would be a monumental effort. It would be the complete opposite of living on Little Earth. This powerful gravity would hold onto a thick atmosphere much denser than what we have now. The air pressure would be immense. Life, if it could exist there, would have to be incredibly sturdy, with strong skeletons and powerful muscles just to move around. It would be a high-gravity world, a place of immense pressure and strength. One of the biggest dangers for Little Earth would be losing its atmosphere. A planet's gravity is what holds its blanket of air in place. With only 1/6 the gravity, the gases that make up our air, nitrogen, oxygen, and all the rest, could slowly drift away into space. The solar wind, a stream of particles from the sun, would strip it away even faster without a strong magnetic field to protect it. Over millions of years, Little Earth could become an airless world, just like our moon is today. Our blue skies would fade to black, and the surface would be exposed to the harsh radiation of space, making life impossible without special habitats. In this strange new system, Little Earth would likely become tidally locked to the Big Moon. This is what our moon is to us now. Tidal locking happens when the gravity of a larger body forces a smaller orbiting body to rotate at the same rate that it revolves. This means one side of Little Earth would permanently face the Big Moon, while the other side, the far side, would always face away into deep space. Imagine, one half of the world would have the colossal Big Moon hanging motionless in the sky day and night, while the other half would never see it at all. It would create 2 very different cultures on one small planet. So, could we live on the Big Moon? If it grew to Earth's size and mass, it would be our best bet for survival, especially if Little Earth was losing its air. We would have to build colonies there. But remember that intense gravity? Our technology would have to be incredible. We'd need buildings made of super strong materials to withstand the immense gravitational forces. We'd probably need to wear powered exoskeletons just to walk around without being exhausted or injured. It would be a challenging existence, defined by a constant heavy struggle against the planet itself. But humanity is resilient, and we would find a way to adapt. Life inside these Big Moon colonies would be very different. Perhaps we would build our cities underground to protect us from the thick, heavy atmosphere and any potential radiation. Or maybe we would live in vast, reinforced domes on the surface. Transportation would have to be completely re-engineered. Instead of cars, we might use powerful lift systems or vehicles that could counteract the intense gravity. Our entire way of life, from how we build our homes to how we grow our food, would have to be redesigned for this high-gravity environment. It would be an engineer's dream and a biologist's challenge. Ultimately, this scenario flips our perspective on home. The world we knew, Little Earth, would become the moon in the sky, a beautiful but likely uninhabitable reminder of our past. Our new home, the Big Moon, would be a world of immense challenges but also immense possibilities. It shows us that the laws of physics, especially gravity, are what shape everything from our bodies to our planets. By imagining these cosmic what-ifs, we can better appreciate the very special and perfectly balanced world we live on right now. Science helps us understand not just what is, but also what could be. Consider that.